Alright, what's up guys? In this video we're going to pick up some calculus here, and we're going to be talking about finding the derivative of a function using the derivative definition. So we're given this function f of x is equal to 3x squared minus 19x, and we want the derivative of that using the derivative definition. Okay, so I'll write down the derivative definition, but first of all let's just take the derivative just by hand, right off the top of our head just immediately, and we'll see what we get when we actually do it. So what's the derivative of this? Okay, well, if we take the derivative of 3x squared minus 19, we'll essentially just get 6x minus 19. Now what we're going to do is we're going to use the derivative definition to prove that that's what it is. So let's write down the derivative definition. Alright, so the derivative definition, that's just f prime of x is equal to the limit as h goes to 0, and it's going to be f of x plus h minus f of x all over h. So basically what we're doing is we're substituting in x plus h for every place we see an x. So this would be 3x plus h squared minus 19 x plus h minus our function, which is 3x squared minus 19x, and then we're dividing all of that by h. So no real calculus or anything like that going on here. We're just kind of using a bunch of algebra to expand everything out. I'm actually going to, let me do some of the work over on this side. So what's x plus h squared? Well, that's just x squared plus 2xh plus h squared. Let's go ahead and simplify the other side. So that means that we would have 3 times all of that, so that would be 3 times x squared plus 2xh plus h squared. So we'll need to distribute that in, and if we distribute that in, it looks like we'll get 3x squared plus 6xh plus 3h squared. And we'll need to simplify the inside here. So we got negative 19 times x plus h, and that obviously gives us negative 19x minus 19h. Now I'm going to group like terms, that way we can simplify it down a little bit. So it looks like we got a 3x squared, we got another 3x squared, we got a plus 6xh, we got a minus 19x, we got another 19x, and we got a 3h squared, and then we got a minus 19h. So we simplify this. The best thing to do, because it is a lot of canceling out that has to be done, group like terms, that'll make it easier. Okay, so it looks like that's gonna go, that's gonna go. So it looks like we're gonna end up with 6xh plus 3h squared minus 19h. So if we go back up here, we'll have 6xh plus 3h squared minus 19h, and that's all over h. So we simplify, and we essentially take it from there. So we need to cancel a common factor of h, so we'll have the limit as h goes to 0. And after we cancel a common factor of h, but before we do that, we're going to have to factor out an h. So let me do it this way. So if I factored an h out, I'd have h 6x plus 3h minus 19. And you can always distribute the h back in to make sure that you factored it out correctly. And so now, as you can see, the h's go away. And so now what we're left with is the limit as h goes to 0. And now that we canceled out the h at the bottom, we just got 6x plus 3h minus 19. Now we take the limit, and if we plug it in, notice that we'll simply get 6x plus 3 multiplied by 0 minus 19. And this obviously gives us 6x minus 19, which is the exact derivative that we got on top. So for our final answer, using that derivative definition, we simply get that f prime of x is going to be 6x minus 19. And that's how you find the derivative using the derivative definition. And that's your answer. All right, so let me know if you got any questions about how I got my answers. We could talk about it. I'll see you guys next time.